video is the introduction of chapter 5.4, conditional probability and the general multiplication rule. So again, have your note sheets and have your book open or the PowerPoint that I've provided. And so we introduce a new symbol for you. It's right here. It's this line, it's that solid line there. And how that is read is, the notation is the probability F given that we know E has already occurred. The probability of event F given event E has happened. It's what's called the conditional probability. And in real life, that is actually what happens a lot in our life, and that everything, the probability of something happening is dependent upon or on some other event. And if that event happens, it changes the probability. You update those probabilities. And so just to give you an example what I mean by conditional probability, suppose you roll a die, right? This is non-conditional. This would be a non-conditional probability. Condition meaning that there is a condition, conditional. Non-conditional. What's the probability of rolling a 3? That's 1 out of 6. Easy enough. Now in this case over here, we have one that's conditional. Let's say you roll the dice and someone tells you the number is odd. And so what now is, what's the probability of rolling 3 given that you know the answer is odd? What's the answer on that? Well, the answer on that would be 1/2, or technically 3 out of, sorry, let's do that again. Not 1/2. So let me write this out actually. You have the numbers 1, 2, 3, 4, 5, 6, and someone says, what's the probability of rolling a 3 given that you know it's odd? And so here are the odd numbers, 1, 3, 5. And so what are our choices now? The probability of rolling a 3 given that given that you know it's odd is going to be not 1/2 like I said earlier, it's going to be 1 out of 3. There's 1 out of 3. So that's an example of conditional probability, okay? And so we just kind of figured that out by doing computations. And so there's actually a formula for that. It's a little complex. If E and F are two events, then the probability of F happening, given that E already occurred, is solved using one of these two values. You can either solve it through probabilities, which are here, or through by counting how many are in this situation, right? So one has to do with the number, and this has to do with the probability. So it can go either way with that. And so in this case, looking at that formula, and so if we wanted to try to apply this formula to the situation up here, we could. I don't want to, let's try this without confusing you here. So what we know is the probability of being a 3 given that's odd. What we would do is we would basically say probability of a 3, so that's your F, given that it is odd. That would be your E part, is going to be equal to the probability of E and F. So the probability of E and F of being odd and a 3 divided by the probability of E. E in this case is odd. So that's the probability of being odd. And so we can do the calculation. Well, what's the probability of being odd and a 3? Well, how many odd numbers are there? There are 3 and a 3. So there's only one situation that matches that. There's only one 3 that's odd. So this would be 1 out of 6 all over the probability of being odd. Well, how many odd numbers? 3, and that is 3 out of 6. Again, how many numbers are odd and 3? There's only one value, 1 out of 6. That's where that comes from. And then this just becomes 1/6 times 1/6 times 6 over 3. You reciprocate, 6 cancel, there's your 1/3. And so that matches up with what we have here. Moving on, okay, so that was quick, but again, that was a little bit kind of a weird situation with this, but you can see that you can apply the formula. Let's try this again with counting how many we have here. Compute the probability. Let me see if it has some space here. Compute the probability for A, the probability that the individual never married, given that the individual is male. Okay, so we're looking for those calculations there. And so in this case, this is my F and this is my E, so then we can apply the formula. In this case, we're given numerical values, here, not probabilities. And so we're going to use this other situation. How many situations? How many here? So we're going to use this one here. The number that are E and F. So we're looking for how many are male and never married. And so in this case, what we're looking for, the number that are male and never married divided by the number, the E situation is male, the number that are male. And so we just count that up. So how many are male and never married? Male and never married is 41.6 divided by the number of male. Never married, given that you're male, the number of male is 122.5. And so then that's your probability by counting that up. Let's look at B. Oh, we need to simplify that, so I would need to get the calculator out to get that down. I think I have the calculation in front of me. It's I thought I had it. Oh, let's go with let's get the calculator out and solve that real quick. So it's 41.6. 41.6 divided by 122.5. And I got those numbers from here. And so the answer is equal to 0.339, one more decimal, so 0.340. And so this is 0.340 or 34%. Okay. B, what's the probability? Probability that the individual's male, given that they never married, given they're male, given that they never married. So it sounds very similar to the first one, but they're not the same. They're different values. What's the probability of never marrying, given that you're a male, versus what's the probability of being a male, given that you never married? And so in this case, we'll make this is your F and this is your E. And so we're going to use our formula. The number that are E and F, number of E and F. So in this case, it's the number that are never married and male divided by the number that are, and in this case, go back here, it's the number that are in E, event E. Event E is never married. So it's similar. So we go ahead and look at how many are never married and male. So that's again 41.6. So you have 41.6 divided by the number that never married. And in this case, number that never married is right here. That's that value. So it's 78.5. And so now we have calculation again. 41.6 divided by 41.6 divided by 78.5. And so you get that's 0.53. And so this is, so those numbers are different, 0.530, 53%. Okay, so that's our introduction to, oh, no, you know what? Let me sneak in one more example real quick. Birth weights preterm. Okay, finish this example here. Read the situation. Suppose that 12.2% of all births are preterm. This means they were born before 37 weeks. Also, we know that 0.2% of all births, 0.2% of all births result in preterm babies who weigh 8 pounds, 13 ounces or more, so that they're big babies, only a small percent. What is the probability that a randomly selected baby weighs 8 pounds, 13 ounces or more, given that the baby is preterm? So here's what we're trying to find out. Probability weighing 8 pounds, 13 ounces, given that the baby is preterm. So here, this is your, if we go back to our formula here, you have F given E. So this is your F situation, and this is E. And in this situation, we're given probabilities. So what we want to do in this situation is probability of E and F divided by the probability of E. It's because I have probabilities here. In the last problem, I had numbers. And so we're going to use that over here. And so we have these values already. What's the probability of E and F, which is being preterm and 8 pounds or 13 ounces? We have it right there. Being preterm who weighs 8. So this answer would be 0.002, because I got to convert that to a percent. And then we have here also the probability of E, which is preterm, and that is right there. And so that is 0.122. So that's it. That's what you would do to answer that problem. We would just divide those two values, and we have it. 0.002 divided by 0.122. And so we have that. Maybe 0, oh, missed it. 0.16 or 1.6%. That's it.